Let's find the tangent line. The function xy squared plus e to the 2x equals 1 plus ln of y. And we're interested at the point 0, 1. So for the tangent line, we want a point and a slope. We're given the point, so let's find the slope. The way to find the slope is by taking the derivative. So here the derivative is going to be with respect to x. So this is going to be an implicit differentiation problem. So first with xy squared, we're going to use a product rule. So the derivative of x is just 1, and then we're going to multiply that by y squared, plus the derivative of y squared, that's 2y times dy over dx, and then multiply that by x. The derivative of e to the 2x is 2e to the 2x. Derivative of 1 is 0, and the derivative ln of y is just 1 over y times dy over dx. Our goal is to solve for dy over dx, so let's move that all on one side. And just to make things easy, it's better to move the 2y dy over dx times x over. So on the left side is just y squared plus 2e to the 2x. And on the right we have 1 over y times dy over dx minus, and then I'm just going to bring the x between the 2 and the y, so it's 2xy times dy over dx. I'm going to factor out a dy over dx, and we have 1 over y minus 2xy. And so now to solve for dy over dx, we're going to divide both sides by 1 over y minus 2xy. At this point, I don't really care about simplifying, so I'm just going to plug in x equals 0 and y equals 1. So that's 1 squared plus 2e times 2 to the 0, and then 1 over 1 minus 2 times 0 times 1. So that's on the top. E to the 0 is 1, so it's 2 times 1 plus 1 is 3. On the bottom, we have 1 minus 0, that's 1, so the derivative here is going to be 3. So now we go up here, the point is 0, 1. The slope is 3. Notice that when here x is 0, y is 1, this is also the y-intercept. So the y-intercept is 1. And so if we want to use the slope-intercept form, we have slope 3, y-intercept 1. And so this is going to be our tangent line.